Hi, it's Miss Barber for lesson 5.7 in geometry, Pythagorean theorem and its converse. So Pythagorean theorem is a very important ancient theorem that has been known for many centuries, and it is used in right triangles to determine the third side. So given a right triangle, you need to know two sides in order to find the third using the very well-known a squared plus b squared equals c squared. There's a few things that are important to make sure you understand, and that's that a and b are legs of the right triangle. So they're going to be the two shorter sides. It doesn't matter whether you want to call one a or one b, it doesn't make a difference. And then c is going to be your hypotenuse, which is the longest side opposite the right angle. So again, that's what's important to know, and it's just a matter of substituting in what you know and solving. So let's go ahead and try our first example. So example 1a. I'm given two sides of a right triangle and I need to find the third. I like to always make sure I have my hypotenuse, my c, labeled. So I like to draw a little arrow outside of my right angle, and that'll tell me my hypotenuse. So in this case, my hypotenuse is going to be c, or x. So x will be my hypotenuse. It doesn't matter whether you want to call 12 a and b or b and a. It doesn't change. So my formula is a squared plus b squared equals c squared. So I'm going to write 9 squared, substituting it in, plus b squared, which is 12 squared, equals x squared for my c squared. All right? It's important that you know that 9 squared is 9 times 9 and 12 squared is 12 times 12. Sometimes people accidentally multiply by 2 instead. So don't do that. You can use your calculator to help you, but 81 plus 144, which is 9 squared and 12 squared, is going to give you 225. So 225 equals x squared. You might remember from doing Pythagorean theorem in chapter 2 or the distance formula that to undo a square, because I don't want to know what x is, I don't want to know what x squared is, I want to know what x is, that to undo a square, you have to square root. So you're going to take the square root of both sides. The square and the square root are going to cancel, and you'll be left with x equals, on our calculators, which I'll pull up right here, if you press shift or second and then the x squared button on the left, that's how you'll get the, why is it not working? The square root button, there it is, and then we can type in 225. Press enter, and that's 15, meaning 15 times 15 is 225. So we can type that in. So x equals 15. That will be your answer. So going over to letter B, again, I like to label my hypotenuse first. Opposite 90 is 34, so that will be your C. It doesn't matter which side you want to call A or B. I'll call XA and 16B. Those are both my legs. So using Pythagorean theorem, we could say x squared plus 16 squared equals 34 squared. You can right away go minus 16 squared on both sides. So those will cancel, and you'll be left with x squared equals, again, it's very important that you put this in your calculator or you find out what 34 squared is, minus 16 squared. 34 squared minus 16 squared is not going to be the same as 18 squared, okay? So it's not like 34 minus 16 is 18, so it's going to be 18 squared. It's going to be whatever 34 squared is minus 16 squared. Well, that's going to be 900, putting it in your calculator. Again, we have to take the square root of both sides to get rid of the square, and we'll be left with x is 30. So your third size that you are trying to find is 30. Letter C. All right, opposite hypotenuse is x. So I'm going to say 6 squared plus 9 squared equals x squared. I'm trying to find my hypotenuse. These are on the same side of the equation, so I can combine them, and that's going to be 117 equals x squared. When I take the square root of both sides, the square root of 117 is not a whole number. It's actually 10.8, roughly rounding. So you'll sometimes see the answer as 10.8. You might also see it just written as the square root of 117. It kind of depends on the book or the SAT problem, whatever it might be, but both of them are acceptable answers because the square root of 117 is 10.8, and so either it depends where they want it in decimal form or they say simplified radical form. Last is the word problem number 25. We're talking about right triangles, so we always know we should draw a right triangle picture. It says a 25-foot ladder is leaned up against a wall. When I think of a ladder leaning against the wall, I know that's going to be my hypotenuse. So a ladder is always the hypotenuse of your triangle. Ladders lean against walls. They don't go straight up and down. It says if the base of the ladder it's cut off, but 7 feet from the wall, so the base is 7 feet. So I'm going to write that at the bottom. How high up the wall will the ladder reach? So I'm going to draw 7 here at the base, and I'm trying to find the height, which is h. So that's my picture. Just like always, I need to label my hypotenuse. So opposite the 90 will be your hypotenuse, which is c. Doesn't matter whether you want to call 7 or h, a or b. So I'm going to have 7 squared plus h squared equals 25 squared. I need to get h squared by itself, so I'm going to subtract 7 squared from both sides. Again, use your calculator to help you. You're going to get 576, 25 squared minus 7 squared. And then I have to, last step, take the square root, and h is 24. So the height is going to be 24 feet up the wall with correct units. So that's how to apply Pythagorean theorem in some situations. And you'll notice in some of these answers, we got whole numbers. So letter A, B, and D, we got whole number answers. But in letter C, we got a decimal answer. That's because A, B, and C are what's called a Pythagorean triple. So a Pythagorean triple has to have 3 whole numbers that satisfy your Pythagorean theorem. A squared plus B squared equals C squared. So again, letters A, B, and D from the problem above all gave me whole number answers, so they're all a Pythagorean triple. Letter C did not, that was not a whole number, so that was not a Pythagorean triple. So here are some common, we're going to fill out this table with some common Pythagorean triples. Remember, it's going to be leg squared plus leg squared equals hypotenuse squared, and you have to take the square root of your final answer. Well, 3 squared plus 4 squared equaling c squared. To figure out what my hypotenuse is going to be, 3 squared plus 4 squared is 25. So c squared is going to be equal to 25, so we could take the square root, and this will be 5. 3, 4, 5 is a very common right triangle side length, so that happens a lot. We'll do one more together, and then you could pause the video, try to fill out the rest of the table, but I'll also fill it out for you. For the second one, I'm trying to find my leg, so I'll call that A. So it's going to be A squared plus 12 squared equals 13 squared. Again, I'm going to subtract 12 squared from both sides. I'm going to be left with A squared equals 25, and square root it. When you do, you're going to get 5. So 5, 12, 13 is another type of triangle. And again, you can pause the video, make sure you've got Pythagorean theorem down by trying to fill out the rest of the chart. But how it goes is 7, 24, 25, 8, 15, 17, 9, 40, 41, 11, 60, 61, and 15, 112, 113. So sometimes you might have a math teacher or another student that automatically knows an answer to a Pythagorean theorem problem, and you think, how did they do that in their head? They probably didn't. They just had a Pythagorean triple memorized, or it happened to be a multiple of a Pythagorean triple. So in example 2, I have triangles. They're all Pythagorean triples, and you could either use Pythagorean theorem, or you could notice which triple that it is a multiple of. We still have to make sure we know which one's the hypotenuse. So in letter A, I still have to make sure I know that my hypotenuse in this case is x. That's my C. Writing my sides down in order from least to greatest is going to be 12, 16, and then my third side that I don't know. If you look at your chart, 12 and 16 are not up there. However, I can divide out a factor that 12 and 16 both have in common. Well, in this case, 4 goes into both 12 and 16. So if I divide all by 4, 12 divided by 4 is 3. 16 divided by 4 is 4. So now you can look at your chart. 3, 4, to finish my triple off, it's going to be 5. I divided by 4 to get to 5, so to multiply by 4, I'm going to get that my hypotenuse is 20. Again, you don't have to use Pythagorean triples. You're more than welcome just to apply Pythagorean theorem to each of these. But it is a shortcut and sometimes a quick way to do something if you don't have a calculator, but you're pretty good with finding multiples. Let's try the next one. Again, I need to know what my hypotenuse is. It's still x in this case. Writing my numbers from least to greatest, it's going to be 50, 120, and then x. Again, 50 and 120 are not on my table, but I do see a number pretty similar, and that's just if I divide both by 10. Dividing them by 10, I'm going to get 5, 12, and then now in my table, it says the third number will be 13. I had to divide by 10 to get my triple, so I'd have to multiply by 10 again to get my answer, and that will be 130. All right, last one, letter C. In this case, my hypotenuse is 100. So I'm going to write it as 28 because that looks like it's the smaller side, x, comma, 100. 28, 100, are not on the table, but they are both divisible by 4. So I'm going to divide both by 4. 28 divided by 4 is 7. I don't know what that one is. 100 divided by 4 is 25. Now looking at my table above, 24 fills in. So it's going to be 7, 24, 25. I had to divide by 4 to go this way, so I'm going to multiply by 4 to go back up. 24 times 4 is 96. So that's another way to find sides using Pythagorean triples, but that doesn't mean you're always going to be able to use it. Again, Pythagorean triples are whole numbers only. Last thing is the converse of the Pythagorean theorem. What the converse of the Pythagorean theorem says is, so the middle one we already know, if a squared plus b squared equals c squared, then the triangle is right. The one on the left and the right are the new ones. If a squared plus b squared is greater than c squared, that means your c, your hypotenuse, shrunk, then your triangle is acute. If a squared plus b squared is less than c squared, that means your triangle, your hypotenuse got bigger, so your triangle is obtuse. Please remember that we still have to apply the triangle inequality theorem to know, is it a triangle? So before you do this, you always have to ask yourself, is it a triangle? Meaning, is a plus b going to be bigger than c? If a plus b is not bigger than c, then it's not a triangle. It doesn't matter what Pythagorean theorem converse tells you. So you first always have to check this before anything else. So let's try example 3a. So my two smaller sides are 10.5 and 36. So I'm first going to check to see, is it a triangle? So is 10.5 plus 36 greater than 37.5? Well, I don't actually have to find that number out. I know that 10.5 plus 36 will be, so it is a triangle. Now for Pythagorean theorem converse, I'm going to square everything. So I'm going to say 10.5 squared plus 36 squared. I don't know how it compares, so I'm going to leave that blank to 37.5 squared. Putting just 10.5 squared and 36 squared, adding them together in the calculator, I get 1,406.25. 37 squared is 1,406.25. Comparing these two numbers, these numbers are equal. So because they're equal, this is a right triangle. So that's how you apply Pythagorean theorem converse. So we're going to repeat that process again in letter B. So again, first we must check, is it a triangle? So is 8 plus 21 going to be bigger than 27? Well, 8 plus 21 is 29, so that will be bigger than 27. It's a triangle, so now let's keep going. You're going to square everything, so 8 squared plus 21 squared. We don't know how it compares to 27 squared. That's what we're trying to figure out. 8 squared plus 21 squared in the calculator is 505. 27 squared is 729. Comparing these two numbers, 729 is bigger. So because your c squared is bigger, this is an obtuse triangle. That's what the chart above tells me. It'll be obtuse. So let's try the same thing for letter C. Again, is it a triangle? So first check, is 18 plus 23 bigger than 25.2? It definitely is going to be. So now let's square everything and compare. 8 squared plus 23 squared, compare it to 25.2 squared. 8 squared plus 23 squared, A and B squared, are going to be 853. 25.2 squared is 635.04. Comparing them, 853 is definitely bigger. So in this case, A squared plus B squared is bigger than C squared. So this is an acute triangle. So that's how you do these problems. We'll do letter E together, and then you're going to need to try D and F on your own. Lastly, letter E, I'm going to first check to see if it's a triangle. So I'm going to do 5 plus 9 is greater than 15. This is actually not true because 14 is definitely not bigger than 15. This is not going to be a triangle. So we don't actually have to go any further. We don't have to do Pythagorean theorem converse. That's just going to be our answer. It can't be an obtuse triangle or an acute triangle if it's not a triangle at all. That's because if you were trying to draw this, this would be 15. Your one side would be 5, so it would go about a third of the way touching. And then your other side would be 9, so it would go almost 2/3 of the way, but there would be a little gap because of the at more than one place it's missing to add to something greater than 15. That's it for lesson 5.7, Pythagorean theorem and its converse. And you're going to need to apply Pythagorean theorem a lot in the future. Think about finding the height of a triangle, which you need to find the area, and lots of different things you use Pythagorean theorem for. So make sure that you really understand this lesson and you know when to apply it. So going forward, you can